These are the preview exercises for College Algebra Lesson 17. We want to find the domain of each function. Remember that domain is a set of numbers. We're going to use interval notation or set builder notation to describe the domain. So for f of x, part A, I see that this is a rational function, and which means it's a fraction, and the bottom of a fraction cannot be 0. Okay, so the only things I have to be careful about not plugging into this function are anything that would make the denominator 0. So I'm just going to say, okay, my domain is the set of all x's such that the denominator is not 0, can't be 0, which means that x can't be 3 and x can't be -1. And if I write this fully in set builder notation, I would say the set of all x's such that x is not 3 or -1. And when you look at a graph of f, this was generated with a computer, you can see that at 3 and at -1, the graph actually doesn't exist. Okay, so I could draw these in, and they're called asymptotes, these vertical lines. The function doesn't exist there, okay, because those values are not part of the domain. We can get very, very close to those values, but you can't actually put them into the function. Okay, for g, I'm looking at a square root, and the thing that has to be true about a square root in order to avoid imaginary numbers, the stuff under the radical has to be positive or 0. So I would say 3x plus 12 has to be greater than or equal to 0. And then I would solve this for x. So I'm subtract 12 from both sides. 3x is greater than or equal to -12. And then divide both sides by 3. X is greater than or equal to -4. Okay, so set builder notation, I would say the set of all x's such that x is greater than or equal to -4. Interval notation, I would say bigger than -4 would mean -4 is the smallest, and I go to infinity, like that. And when we look at the graph, you can see that the graph only exists from -4 and to the right. Okay, so starts at -4 and to the right it exists. Over here is just empty space. There's no graph there.